Thank you guys. Okay, we'll start our today's session. Very good evening to one and all. Last class you have been discussing about primitive roots, right? How to find primitive roots in a given group. Right? And I can also able to call the particular group as a cyclic group. Okay, if it is having a primitive root in the group. Okay, how in the sense, for example, if we take this group, a finite multiplicative group which has elements from Z10 star, right? So we take Z10 star, the elements are 1, 3, 7 and 9, right? If you remember properly. Among these four elements, the element 3 and 7 will be primitive root to this particular group. When you can able to find number of elements in this group by using the order of the group called phi of 10, is tell me as 4. And if you take phi of 10, it will tell me how many number of elements are the primitive roots. Okay. So we have two primitive root values, called 3 and 7. So what is the speciality of this primitive root here in the sense? We can able to create all other elements in the particular group using the primitive root itself. You can able to see an example here. Okay. In the primitive root element 3 is a primitive root. If I raise the power of 3 to 3 power 1 mod 10, I'll be getting 3. Right. And 3 square is 9. 9 mod 10 is 9. 3 cube 27. Mod 10 is 7. And 3 power 4, which is 81. Mod 10 is 1. And you can able to see the elements are 1, 7, 9 and 3. And I can able to see, I can able to generate all these four elements in this particular group using these two values of 3 and 7 alone. That is, with 3 also you can able to get, or you can able to 7 also. 7 also you can able to say, if you raise power to 7 power 1, I'm getting 7. 7 square 49 mod 10 gives me 9. 7 cube gives me 3 and 7 power 4 gives me 1. So if you take any finite multiplicative group, and if suppose a primitive root is present in a particular group, then I can able to call that group as a cyclic group, because I can able to create the elements in the group using a primitive root itself. Right. So when can you able to call a group as a cyclic group in the sense if it has a primitive root? That is the first condition. If it has primitive root, I can able to call them as a cyclic group. If a group is made up of elements of Zp star, that is Zp in a sense with respect to prime number, it will be always cyclic, because we already saw the condition of being a primitive root. So whenever your n is in the form of 2, 4 or any prime number to rise into power t, or 2 times of p power t, that is in the form of a prime, right? It will be having a primitive root. So obviously, if your group is made of Zp star, it will be having a primitive root. Thereby, indirectly, we can able to call them as a cyclic group itself. Right? Is it clear, guys, regarding cyclic group? If it is clear, raise your hand so that I will move on to the next topic. Yeah. So based on these things, what I just discussed, we'll be discussing about discrete logarithm in the upcoming modules. Okay. Now we move on to elliptic curve arithmetic, one of the most important topic in all our 6 modules, because this elliptic curve arithmetic is worthy for 10 marks, and it is a base for our elliptic curve cryptography technique, which we'll be studying in our next module. Right. So if you take most of the public key cryptography techniques like RSA algorithms, okay. Okay, one of the major disadvantage in this RSA based public key cryptographies are nothing but a key length. The key length will be very high, making the load for the entire system to be heavy. Okay, now to reduce this key length, okay, they introduced a method called elliptic curve arithmetic, which is called as elliptic curve cryptography. Actually, elliptic curve cryptography is not like a separate cryptographic technique. It is like an add-on, like how we have add-ons in our browsers, right, to assist us. Same way, elliptic curve cryptography is an add-on to any of the public key cryptographies, so that it can able to reduce the key size. That is, you can able to get a smaller key size there. That is a major usage of this elliptic curve arithmetic. So you'll be starting to understand this elliptic curve arithmetic. You should be clear with what will be abelian group. I hope everyone are clear with abelian group. So if you take elliptic curve arithmetic, the elliptic curve arithmetic will be governed by an equation which has two variables along with some real number coefficients. Okay. And everything will be coming under a finite field, Galois field kind of structure. So before we move into elliptic curves, okay, we will discuss everything which is based upon real numbers. Then we jump into elliptic curve arithmetic into which can be used inside any Galois field or not. So the one thing people have to remember in elliptic curve arithmetic in the sense, here we can able to perform two binary operation of addition and multiplication. Addition will be used as a normal one, whereas your multiplication will be defined by a repeated addition. So whenever I say repeated addition, it means that here if it says that is k times of a, okay, so a will be repeated k times and it will be added. Like this only will be performing the multiplication elliptic curve arithmetic. Right. To start off with, we will go with elliptic curves over real numbers. So elliptic curves means not ellipse. Okay. Why we got? I mean, they kept the name as elliptic curve in the sense. So it is based upon a cubic equation, which is looks similar to the equation used to calculate the circumference of an ellipse. So the circumference of an ellipse is calculated using a Weierstrass equation like this, where you can able to see we have two variables called x and y here, and coefficients are a, b, c, d, which are real numbers. Okay. So we'll be using similar kind of expression, but for our purpose, okay, we are going to limit the equation into this one, not exactly the same thing. Our equation will be this one: y square is equal to h cube plus ax plus b. I want everyone to note down this expression with you now. Kindly note down this expression with you now. That is y square is equal to h cube plus ax plus b. So this will be the governing equation of elliptic curves. Based on this only, we'll be developing all our need for cryptography. And this elliptic curve arithmetic will be having a single element. A single element, it's also called as identity element. How we have identity for element for our multiplication process, for addition process, similar way. Here we have a single element called O, and this will be called as point at infinity or 0 point. Generally, this O is being referred to as an identity element. Can anyone tell what is the identity element for addition operation? We have two elements for, I mean, one for addition, one for multiplication. What is the identity element for addition? Anyone can you tell if you remember properly? If you remember definitions of group, ring, and field, in group, the fourth property, existence of identity, we used to write like this. That is, if you have a identity element called E, A dot E equal to E dot A, again will reveal me A. So based on this dot is, can take either addition or multiplication. Based on this addition multiplication, E will take values of either 0 or 1. Right. So can you people tell what is the identity element for addition operation? Any idea? No. So for addition, your identity element will be 0. Then only if you add a plus 0 will be equal to 0 plus a will be equal to a. Right. So in this expression, we be given two constant values, positive values of a and b, sorry, not positive, a and b value, which can consist of both positive as well as negative values. Okay. So that we can able to plot y with respect to each value of x. And here the elliptic curve will be symmetric about y equal to 0. This is how the elliptic curves will look like for different values of a and b. For your understanding here, this expression, that is y square is equal to x cube minus x, right? So I hope you have your general expression as y square is equal to x cube plus ax plus b. Right, this is general expression we have. Suppose I am substituting a is equal to -1 and b is equal to 0, I will be getting this expression. Okay, for this expression, if I vary the values of x from 0 to infinity, I will be getting different values of y, and if you plot, I will be getting a graph like this. Whereas in this expression, if I substitute a is equal to 1 and my b is equal to 1, my curve expression looks like x square is equal to x square plus, sorry, x cube plus x plus 1. Right, this is for a is equal to 1, b is equal to 1. Right. So this is how what we just saw. Okay. Now we move on to geometric description of addition. So how we can able to add 2 points over the elliptic curve. Assume that we have like 2 points like this, P and Q. Okay, how we can able to add these 2 points P and Q here. Right. So before moving into this one, the people should be clear that the values of A and B will be chosen in such a way that it satisfies the following condition. That is 4a cube plus 27b square not equal to 0. Don't worry, in examination we will be providing the values of a and b. Okay, this is only for your understanding here. So, okay, now we move on to the rules of addition over an elliptic curve. So already, as I said, O will serve as a point of identity. So whenever you, O will be equal to minus O also. So if you take any point of P and if you perform the addition operation with O, you will be ending up with the same value of P, provided P is not equal to O, and if there is another point like Q, Q is also should not be equal to O. Okay. This is the first point you people have to remember. Second, negative of any point P. If you take any point over the curve, okay, we will be having a negative version of that point, because if you see this curve, you can able to see it is symmetric about y is equal to 0. You can able to see, we draw a line here. Right, you can able to see it is symmetric about this point. Whatever you see in this quadrant will be a mirror image of this quadrant. Right. So there is a negative point of P in the point. For how we can able to create, get that point in the sense, keep the x coordinate as same but change the y coordinate by negative sign. That is, if you have point P as x comma y, okay, you will be writing a minus P as x comma minus y. Why? In the sense, if you add those 2 points, P plus minus P, will be ending up with the identity element. Oh, we'll see how this occurs. Okay. Suppose if there are two different points, okay, with different coordinates lying on the curve. Assume we have 2 points P and Q lying on the curve. Okay. If I draw a straight line between them, that is, if to add 2 points, you have to draw a straight line connecting these 2 points, and it will be intersecting the curve at the third point called R. You are able to see here. Let me go here. I have 2 points P and Q. If I join this line, it is going to intersect me with a point called R. That is, R will be equal to minus P plus Q. That is minus of P plus Q. If you add P plus Q plus R, it will be giving me the identity point O. And you can able to see the minus version of this one is here. That is your negative version. Yeah, fourth point is nothing but the addition of two points will be leading to identity if they are inverse to each other. Then if you are going to double a point in the sense, if you are going to add a point over itself, that is q plus q or p plus p, or even if you go for triple times, 4 times, okay, you will be getting repetitive addition here. We will see this repetitive addition in the upcoming slides. Right. So I hope you are clear with the basic rules of addition here. If it is clear, raise your hands. Okay, right. Now we move on algebraic description of addition. How we can able to add? Those are the rules here. How we can able to perform this addition over real numbers. Okay. So for example, I have two distinct points like N Q here. Your HP and YP are the x coordinates of point P. XQ and YQ are the X and Y coordinates of point Q. Okay, and they are not negative values of each other. It is not P is not equal to Q. Right. And if you are joining a line between them, then we'll be getting a slope of the line, right? For example, if this is the point like P and Q, we'll be getting slope for this line, right? Connecting this P and Q. This slope can be found using this formula called del, which is y coordinate of Q minus y coordinate of P divided by x coordinate of Q minus x coordinate of P. Okay, this will give me the value of del. Okay. So using this del, I can able to find the value of XR and YR, because if I add 2 points, we already saw we'll be getting a third point called R. So once you find the coordinates of the third point, it is nothing but a solution of adding the point of P plus Q. So the x coordinate of R can be found using the expression x square minus x coordinate of P minus x coordinate of Q, YR with minus y coordinate of P plus del times HP minus XR. Here you should substitute the coordinate of XR which you are obtaining in the previous step. Right. Suppose if you are going for a self addition, that is repeating a point, repetition of addition of a same point like P plus P. Okay. How we can able to get this value of XR? Because if you are going to repeat a point like if you have a curve like this and I'm repeating a point of P, here I can't able to join a line because here the line will be going like a tangent. Okay, so it won't intersect anything kind of thing. So here you won't have a slope at all. So you can able to see the expression here for XR and YR, that is a result for 2 times of P is then 3 times of HP square plus A. This A is nothing but, if you see this equation, general equation we just came across. Here for each and every curve we will be substituting the value of A and B, right? This value of A will be used here, right? And similarly you will be using this expression to find the value of OER here. So I want everyone to note down elliptic curves over real numbers, the addition formulas in a single sheet now. Already you have noted down the general expression. Now note down the formula for del, and this one whenever your point P is not equal to Q, and this one when both the points are same. Kindly note down this formula. Once noted down, kindly raise your hand. I hope this is very simple for you to understand the formulas. Next, we'll jump into the elliptic curves over Galois field prime number. Then we'll be solving the numericals directly. So once noted down, kindly raise your hand, please. Noted down. Okay. 2. Okay then. Right. Now we move on same elliptic curves over a set of ZP or a Galois field of P. We can go this way or we can go with Galois field of 2 power n. But as of now, we'll be discussing this part alone. Okay. You see, the same expression, the only add-on which I've done with respect to our cryptography is concerned, is I added a modulo operator on both left hand side and right hand side so that I can able to satisfy the equation here. Suppose if a and b is equal to 1, okay, x is 9 and y is equal to 7 and the prime number here is 23, then I can able to satisfy this expression. You can only add on with respect to elliptic curves over real numbers and elliptic curves over this ZP or Gauss field of P. There's nothing but we will be adding this modulo part here. Right. Now, you may be getting questions like this also. I mean, find the points over the elliptic curve, so and so. So this elliptic curve over a point P will be represented like this. E means elliptic curve, suffix P the prime number, and here inside a bracket will be having the values of A and B. For example, here this shows the points on the elliptic curve E23 1, 1. It shows that E23 means your value of P is this one, and we have your A comma B, which is nothing but your 1, 1. So if you substitute this 1 and 1 here, we'll be getting the expression as y square is equal to x cube plus x plus 1. From this, we have to find all the points. Right, I will teach you how to find the points. I want everyone to listen to this carefully. If you have any doubts, stop me then and there. Okay. Because in books, we don't have the thing how to find them. So I will be going with this one. That is, we have the point called, I'll directly write here, y square is equal to x cube plus x plus 1. Okay, and we have the modulo part as for 23. Right. Now, being it is a Gauss field over ZP, we will be having the set of elements from 0, 1 up to P minus 1, that is 22. So for our understanding, I'll be solving up to first 10 points. In examination, if I ask, you have to go with the number of points whichever I ask. Okay. Now I am creating two sides. For example, here, 1 second. Assume this is x, this is x cube plus x plus 1 mod 23. So I need everyone to take their calculators and help me with this one. We have this is your right hand side part of the equation, right? And next one will be my left hand side, y for different values of y. What is y square mod 23? Right. Now I'm substituting x from 0, 1, 2, 3. Actually, this we have to solve up to 22, but for understanding, I'm starting with 1. Now, if substitute x equal to 0, I'll be getting 0 cube plus 0 plus 1. So 1 mod 23 is 1. Next, I substitute 1 here, 1 cube plus 1 plus 1, 3 mod 23 is 3. Okay, 2 cube is 8, 8 plus 2 is 10, 11, 11 mod 23 is 11. So I want you people to tell me the answer for 3, 4, 5, 6, 7, 8, 9, 10 in the chat box. Just substitute this 3 in place of x, solve this one, take modulo and let me know the answer. So once you get the answer for 3, 4, 5, I mean keep on posting, then you can solve for rest of the numbers. Guys, I want a response from you guys. Very simple. Substitute the values and let me know the answer. Then only I can able to teach you this one. So, you can use your chat box to post the answer. Okay, 8. I mean, Arun, you are saying 8 is for number 3, right? Sorry, number.
Yes, sir.
Okay, okay. So once you get the answer, just post like this, like 3 means 8, 4 means what? like that in the chat box. Okay, Venkat, you got it 0 for 4. Okay. 4 you got 0 for 5. For 5 and 6, you'll be getting same answer. Just try. Yeah, for 5 it is 16. Okay. For 6, what is going?
216, 222, 220.
Other people only Venkata Sai, Sandeep, and Arun alone was solving. What about others? Because it's easily 10 marks you can score, not much of anything. Yeah. For 6, you're getting 16. Not much effort you can able to put. Simply you can score 10 marks and more. About 7, 8, 9, and 10. Yes, perfect. For 7, for 7, you're getting 6. Sandeep? Yeah. For 8, 9, and 10. For 8, you're getting 15. Okay. Solve for 9 and 10. And similarly, if you go with y 0, 9, you're getting 3. Okay. For 10, 10 cube is 1000. 1011 mod 23 for 10. We getting 22. Right. Similarly, if I go on towards my y coordinate side, I substitute y equal to 0, 0. For 1, 1. For 2, 2 square is 4. For 3 square 9, 4 square 16, 5 square 25, mod 23, will be getting 2. Right. Similarly, can you people tell me the answer for this one? 36, 49, 64, 81, 100, mod 23. That is 6 square, 7 square, 8 square, 9 square, 10 square. Once you have done this part, 90% of your work is over to get the points. Just tell me the answers for this side 6, 7, 8, 9, and 10. For 6, you're getting 13. Okay. For 7. Guys, if you are getting different answers, someone kindly notify me. I'm just relying on you people and posting. 7, okay. 8, 4 mod 23. Okay, for 10 you are getting. For 10 it is 8. 8 you are getting 18. Yeah, for 9. 9 you are getting 12. Right. Okay. Now once you get like this for all the 22 points, okay, then what do people have to do in the sense? Just check, because I'm going to get a point P's, then I have to get point negative P, because a curve is symmetric about a point. So first, when x is equal to 0, right, the value which I'm getting here is 1. That is, this point, this side is 1. So I have to get this side also 1, means the 1 is present here. So the respective y coordinate will be 1, 1 here. So when x is equal to 0, okay, my y should be 1, then only I can able to satisfy this expression. That is, you can able to see when x equal to 0, I'm getting 1 as output. Again, when y is equal to 1, I'm getting 1 as output. So the first point is 0, 1. Second, I am going for substituting x equal to 1, which gives me 3. And I'm checking where I'm getting this 3. I'm getting the 3 here. Okay, so when x is equal to 1, here the answer is 3. For 2, I'm getting 11 here. And I'm checking here, I don't have 11. Even if you go for up to 22, you won't have 11. So at that moment, you'll be saying that for x equal to 2, we can't have the solution. When x equal to 3, I got answer to be 8. Right, x equal to 3. Y, I am checking where I am getting 8. I found the 8 to be here. So similarly, I got the point 10. Right. Now, whenever you find the point P, parallelly go with your negative side of P. That is 0, minus 1. If I convert this minus 1 into a positive, that is non-negative value, I will be making a 0, 22. That is minus 1 plus this 23. Similarly, if you convert this one, I will be getting 0, minus 3, which will be nothing but 0, 20. And this one, 3, 10. I think there is an issue with this one. Okay, if it is 3, 10, then accordingly we will be getting as 3, minus 10 and 3, 13. Sorry guys, I made a mistake here. It is 1. Like this, you will be solving for all the points. You can able to see 0, 1, it's negative is 0, 22, 1, 7, 1, 16, 3, 10, 3, minus 10 is 3, 13, 4, 0. We can able to see here. Sorry, we have for 4, we got this 0, and 0 is present here. So point is 4, 0, and negative point is 4, minus 0. It will be again 4, 23, right? Or 4, 0 is itself also, because 23 mod 23 is again 0. So it's inverse over each other. And 5, 4, 5, 19 goes on. So like this, if you find all the points, then if you plot, you'll be getting like this. At one point, you'll be able to say that my curve is symmetric about that particular point. Sorry guys.
Points which do not have any common ones will not be considered.
Yes, yes. Suppose if you have a point like as I said, this time the 2 produced a value called 11, but 11 I can't able to find even if you solve up to 22, then you'll be omitting that point. And there are also certain scenarios. For example, let's see. You have 3, 10, 1, 3. So for 3, I got the value of okay. For 5, the value is 16 here. Okay. So I will be writing 5, comma, for 4 I am getting the 16. Suppose, assume that in this place also you have the 16 value. Assume, I'm just saying, suppose. Means at that time, the place where the first time the 16 comes, that point will be taken here. Only 4 will be taken here. You won't take 6 here. I hope you get my point. These are very rare cases. Okay, it will very rarely it may occur. But I'm saying first time when it is occurring, that point alone will be taken. So 5 comma 4 here. Whereas if you take 6 also, I'm getting 16 means again you'll be taking 6 comma 4. Right, then the negative point is 5 comma minus 4. You'll be getting as 5 comma 19. Again, this is 6 comma 19. Right, see 5 comma 4, 5 comma 19, 6 comma 4, 6 comma 19. Like this, you will be solving for all this thing. Yeah, like this, you'll be able to get the entire points. Is it clear, guys, regarding this point? If it is clear regarding this finding the points over the curve, kindly raise a hand. Fine, because very easily you can score 10 marks, guys. Don't miss this one. Because you can score 10 marks in 2 modules like this. Because here you'll be using in elliptic curve arithmetic. In upcoming module, you'll be using the same method for elliptic curve cryptography also. Right. So here, if you are going to add 2 points, okay, over last time we just saw the formula for elliptic curve addition over real numbers. If it is over this ZP or Galaxy field of P, the formula varies here. You'll be getting numericals on these formulas or that one. Suppose if you have a point P which have the coordinates xp and yp and point Q, it's a different point xq and yq. As I said, they are not equal. And then you have to find the addition of these 2 point P plus Q, which will be x and y coordinate of point R. The formula is this one. XR will be lambda square minus xp minus xq. Here the modulo point comes. Similarly for YR, here the only difference in sense the computation of lambda. There, if you're going to make a repetitive addition, we won't use a slope. Here we are going to use a slope for both with when the points are not equal as well as points are also equal to each other. But the formula for finding slope is going to vary here. Here, if a point of, if a P and Q are 2 different points, this is the expression, the same expression which we used for del in real numbers, yq minus yp minus hq minus hp modulo p. When p is equal to q, that is both are same point, then I'll be using 3hp square plus a divided by 2 yp, that is one single point to compute the lambda. Then I'll be substituting the values here. Right, so I want everyone to note down these formulas also. These are nothing but the formulas to compute elliptic curves over ZP or Galois field of P. Kindly note it down. Once noted down, once noted, kindly raise a hand, guys. Okay, Arun, what about others? Have you guys noted? Okay. So I think we will wrap up today's session with this one. Okay, in tomorrow's class, we will see the numericals based on the addition of 2 points over